A few weeks ago, we hopped on a call with a client who wanted to run all of their AI locally. They came in really excited because they could run their models free, completely private, and they didn't have to rely on OpenAI and Anthropic anymore. And honestly, we get the excitement. Everyone's talking about local AI right now. New models are dropping every single week, and on the surface, it looks like the perfect solution. But as we sat on a call with them, something became really clear. They didn't really understand what local AI meant. And more importantly, they didn't understand the trade-offs of going local. Unfortunately, this isn't unique. We have this conversation all the time. I'm Christian, and I'm going to walk you through the exact conversation we had so you can understand what local AI means, what you gain, what you give up, and how we decide if it makes sense for a project. We have clients asking us all the time about local AI models, and 99% of the time they're talking about the same benefits, how it's free to run and completely private. Okay, so the first thing I want to clear up, because this was confusing to me too, was that local AI can mean two different things. There's on-device local AI, so this is actually running on your phone or your laptop. You can think about Apple Intelligence, or even something like Siri is technically a local AI model living on your device. Another great example is dictation, so if you've ever used the dictation function on your phone, that is technically also a local AI model. And a good way to tell if something is local is if it's able to run offline, it is probably a local AI model. And then there's self-hosted local AI. So this is when you take a way bigger model like the Llama 70B model and you put it on your own server. So both of these are technically local because you're not hitting some sort of third party like OpenAI, but they're completely different in terms of what you can actually do with them. I think most of the hype is because people are confusing both of these categories as the same thing. So let's go ahead and break them down. Let's first start with the local on-device models. And these are all things that we learned by actually using these local AI models for projects. On-device AI sounds really good in theory until you try to use it for something more than a simple task. And the reason it breaks down so quickly is actually pretty straightforward. These models have very small context windows and they're not that powerful. Their reasoning capabilities are just not there yet. You end up having to give very small specific prompts, only a small amount of data. And even if you do all that correctly, the accuracy is not usually that high. Let's look at a common scenario we usually get, which is using AI for medical transcription cleanup. There are three main reasons this usually does not go well when you try to do this with a local on-device model. The first is usually the context window is so small you can't fit an entire transcription or multiple transcriptions in one go. The second is its training is a little bit more limited, so it's not going to understand things like medical terminology as well as some of the bigger models or the cloud-based models, so the quality of the output won't meet our standards. And third, its reasoning ability is just not that good, so if you give it instructions like following the doctor's name or formatting in a specific way, it probably won't be able to follow those instructions that well. And yes, there are local models like Whisper which you can load locally on someone's device and it is built for transcription, but in our experience when trying to use it in real-world projects, when you compare it against something like DeepGram, which is not a local AI model, you really can't even compare the two, especially for something as complex as medical transcription. In practice, on-device local AI is really good for things like quick summarization, labeling data, and small rewrites of existing text. But once you try something bigger like summarizing a long medical transcript or analyzing a 20-page report, it falls apart immediately. It just doesn't have the horsepower for that. And this is usually the point where people jump to the next idea. Okay, if I can't run it on my device locally, can't I just get a server and then just run it for free myself? Because in theory, you can download something like Llama 70B, download it, put it on a server, and now it's free, it's private, it's way more powerful, so it's more accurate. It sounds like the perfect solution. So that's actually what we started doing. We started self-hosting these larger models. But as we started doing this, we came to some interesting realizations. The first thing that became clear was it ran incredibly slow. Still completely usable, but when you compare it to something like ChatGPT, which most people are used to, it was running at like a tenth of the speed. So imagine using something like ChatGPT, it takes like 2 to 3 seconds to respond. In our case, it was taking like 30 seconds to respond. And for some use cases, that's completely fine. Like if you're doing medical transcriptions, maybe the doctor can wait 5 minutes for the transcription to process. But for other cases, like let's say the doctor needs a response in the next 10 seconds because the patient's right in front of them, that's not gonna cut it. So we started trying to figure out how to make this faster, and then we came to the second realization, which is that self-hosted models can get very, very expensive. So something that finally clicked for us was that the real cost of local self-hosted AI is not actually the model itself. Technically, the file's free. Anyone can download it and run it. It's trying to get it to run efficiently and match the speed of something like ChatGPT. That's where it gets really expensive. If you're not using powerful GPUs, something that could take 1 to 2 seconds on ChatGPT could end up taking 30 seconds to run the exact same prompt on a self-hosted solution. To do this reliably at scale, you kind of have to make your own little mini ChatGPT infrastructure. This stuff is called inference, by the way, and there's a lot of videos out there on that. Maybe we can make one too. But you're gonna need something like high VRAM GPUs, fast memory bandwidth, parallelization, auto-scaling, orchestration layers. There's just a lot of stuff that goes into running this stuff reliably in a scalable manner. All of this stuff does add up in terms of complexity and cost, and now the phrase, it's free to download but not free to run, makes total sense. If you want to match the speed of the APIs from Anthropic and OpenAI, you have to shell out a couple $1,000s a month at minimum. And as your users scale, that is also going to have to scale as well. For example, in our experience, we were running a very small distilled DeepSeek model on a server for about $100 a month, and the speed was just okay. And that was just with a few users using it as well. Running that bigger model on a more complex task, the tokens per second dropped to around 1 to 2 seconds per token. And again, to increase the speed, we would need way bigger servers, and that would cost probably a couple $1,000s a month to do. And this holds with other models. If you're running something small like Llama 8B, it would probably cost about $100 a month to get around 10 tokens per second. But the moment you swap to a bigger model like 70B, the cost is going to be at least $1,500 a month in our experience to get it around 20 to 40 tokens per second. So knowing what we know now about speed and cost, it makes a lot more sense that people are just using the frontier models from OpenAI and Anthropic because it's just so effortless. You don't have to worry about inference, you don't have to worry about infrastructure. They will run the models for you and you just pay for how many tokens you consume. The main downside is the privacy elements, but there is actually a little bit of a way around that too. You can use services like Vertex and AWS Bedrock to run these in a way more private way, and it is actually HIPAA compliant. We have some videos on our channel if you want to go check that out on how we run AI models in a cost-effective and HIPAA compliant manner, so go check that out if you want. But for some people who can't even use services like Bedrock and Vertex, you will have to go the more expensive route of running these models locally. Once you have a good understanding of all of these trade-offs, it becomes a little bit more clear what you should choose for what specific situation. When you decide to use a local AI model, what you are typically doing is you are trading speed, accuracy, and reasoning for privacy. Here's how we decide which models to recommend to people. If privacy is extremely important and the task is really small, we're talking about data labeling or small suggestions, then on-device AI could actually be a good solution. This is great for tasks that are also going to happen very frequently, like 50+ times a day, because it's basically free since it's running on the user's device. But just remember, you can't expect it to do anything complex or with a large amount of data. Now, if you still need privacy, but the task is more complex and you have the budget to set up infrastructure, that's when self-hosted models like Llama or Qwen could be a really good solution. This is the route we recommend for people in the financial and medical space where they need the highest level of privacy. They're dealing with sensitive medical or legal data that cannot leave their environment even when encrypted. You get the privacy in the bigger model, but again, it does come with the trade-off of cost. You will need to run that very costly infrastructure yourself. If the top priority is accuracy and speed and you can sacrifice a little bit of privacy, then you just cannot beat the frontier cloud-hosted models. If you are in a situation where there is a lot of compliance and you do need that enhanced privacy, again, Vertex and AWS Bedrock, this is a way to run these frontier models in a very secure way. You kind of get the best of both worlds. You get the frontier model and you get the privacy accuracy and you don't have to run the infrastructure yourself. For most projects we work on, we typically do recommend running the frontier model on something like AWS Bedrock and Vertex. What we have found is the case where the privacy is so strong, where you're willing to take a hit on the accuracy and the speed, usually it's pretty rare that we run into situations like this. Local AI just cannot deliver this stuff without those serious trade-offs. The good news is local AI models are continually getting better and better. I can definitely see a future where running everything locally on your device totally becomes normal. But right now, the gaps in speed, cost, and accuracy are very real. And the reason we're making this video and we talk about it so much is we want people to understand what those trade-offs are before they try to jump in and rewrite and make everything local. Because everything looks good on paper, but it does not hold up in practice. If you're trying to figure out the right setup for your company, feel free to leave a comment below, or I'll leave a link in the description if you want to talk to someone like me or someone on my team, and we can give you a specific recommendation on your situation. If you want to see more AI videos, I will leave a link to a playlist below, but thank you so much for watching, and I will see you in the next video.